Hello, good morning. In this class, we are going to see about logistic regression. So far in your econometrics course, you have heard about regression and you know what regression is. Okay, we can say that it's a functional relationship between y and x. It's not just relationship, but functional relationship. That is, any change in y is a function of x. So x with x, we will be able to estimate the average effect of x on y. Okay, that is what regression is all about. So we have the actual value as well as we have the predicted value. Okay, so that predicted value of y is estimated by the regression model. Okay, but here what we have the keyword apart from regression, what we have over here is logistic. So here, what is logistic regression? So how does logistic regression is different from an ordinary simple linear or multiple linear regression, and how to estimate it, and if at all we are able to estimate, how to interpret it, because in logistic regression we'll be having even higher in interpretation, but basically how to interpret. We have got now advanced statistical or econometric software packages like Stata, where it is very easy to obtain logit. Simply you just have to type logit, and then you have to select your dependent variable and all the independent variables concerned. Then it will make iterations. That is, it will try again and again uh, at various stages. First stage, for example, first iteration. Let us say iteration 0 to 5. Iteration 0 will be, it won't be taking any independent variables. It will be one independent variable and no independent variable. Then it will introduce the independent variable one by one. Okay, so it will be having so many iterations with so many attempts, and then the model will converge and you'll be given the output consisting of the logistic regression coefficients. Okay, and then you can do further estimations on the basis of the output that is given by Stata. Okay, like that, even in SPSS, another advanced or basic statistical or econometric software packages, we have all these facilities. But how to do it in Excel? So for to do logistic regression in Excel, we need to have some basic understanding. So this lecture is all about introducing you introducing you about logistic regression and how to estimate the same in Excel. Okay, let us go step by step. Now, first, we are familiar with this regression equation, right? If we could do it, y is equal to alpha plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus error term ui. So this is error term. So what is this all about? It captures the effect of all other independent variables which have not been included in the model. So here we have included only 3 independent variables, 1, 2, and 3. So these 3 independent variables may not be sufficient to capture the change of the different variable y, or the variation in y cannot be captured by the independent variables x1, x2, x3 that are included in the model. Apart from that, there may be other variables as well which can explain y and which we have not included. So that is captured by the error term. Okay. Now here, instead of just y, what if we have logit of y as the response variable? So here we have y, that is actual value of y as a response variable. So what do we have to do if we should have something called logit of y? Now we know what y is. What is logit? So logit is nothing but the output is represented as natural logarithm of the odds. Okay. So here, when we are taking a simple linear regression, we'll be having y as continuous variable. Okay, what is continuous variable? It will be having a series of values, okay, which are continuous. For example, you take yield of a farmer. So if you ask for yield of a, it can be 12 kg, 14 kg, 28 kg, or 1 quintal, 2 quintal, 1.1 quintal, 1.2 quintals, like that. The yield can be continuous. Similarly, the independent variables can also be continuous. Okay, so when both are continuous, then it is easy for us to estimate regression. But suppose if the dependent variable happens to be a categorical variable, for example, if you are asking a farmer whether the farmer has adopted a technology or not. Then you will be given a response, yes or no, qualitatively. And then what you're doing is you have to give a code so that you'll be converting the qualitative data into quantitative ones. So for example, if the farmer has followed a technology, then one, that is what your code is. And if he is not following technology, then zero. So 1, 0, 1, 0. If you have got a response from 100 farmers, then according to the response given by the farmer, he'll be having to code 1, 0, 1, 1, 1, 0. So the different variable is not continuous because it is taking only two characters, either 0 or 1. So it is dichotomous. Okay. Now in this case, the normal regression, okay, linear regression that where we use OLS estimator, ordinary least square estimator would suffice because the different variable has got two characters, 0 and 1. It is not continuous. Thing is that in a regression, when we do, the different variable should be continuous, right? And the independent variable may or may not be continuous. For example, we know the case of dummy variable, right? For example, if you want to identify the effect of intervention in district, then you can have district dummy. Okay, and then if you want to see if your different variable is yield, okay, and then you want to see whether there is any change on the basis of the land holding, status of the farmer. You want to see whether the land holding status of the farmer has got any influence on the yield component. For there, what you can do is, if you have small farmer, marginal farmer, large farmer, then you can give some dummies. For example, we can have two dummy, because to avoid dummy variable trap, we can always go for, if you have got three categories and you have to see what is the effect of those categories on the different variable. Then accordingly, if you've got small farmer, marginal farmer, large farmer, you can keep one farmer as a base category, right? Then you can have D1, D2. For example, you're keeping large as base. You can have small farmer D1, then medium farmer D2. So you can introduce two dummies over there. So then you'll be having, depending on the response given by farmer, you'll have 1, 0, 1, 0. But so in independent variables, you can always have dummy variables. Then that is okay for you to do regression. Then, for example, if you want to interpret, then you have to interpret keeping the large farmers as base. Okay, then what is the effect of the small farmer over yield? Like that, you can interpret. But here, the thing is that when the dependent variable happens to be dichotomous, binary, consisting of binary responses instead of continuous, then what to do? So that is why we have this one, logistic regression, where instead of just why we have logit of y, that is, we have output as natural logarithm of the odds. So we all know what natural logarithm is, okay? Log base e, that is, e can be 2.718. What is odds doing over here? And if your dependent variable happens to be technology adopted, not adopted, then there we have odds, probability of the farmer, adopting technology to the probability of the farmer not adopting a technology. That is, or we can see instead of technology, we can have event. Probability of the event happening to the probability of the event not happening. When you are tossing a coin, you can say what is the odds of the coin, turning up as head or tail. So we have odds, that is the probability. So that is why the odds ratio can be given as P upon 1 minus P. P is, it's about the probability of the event happening. Then 1 minus P is about the probability of the event not happening. Then when we say log of odds ratio, we always mean natural log. That is why logit is called as natural logarithm of the odds. Okay. So log of odds ratio, or in particularly natural log of odds ratio. So it's nothing but log of P upon 1 minus P. Now you see this Y, that is actual value of Y. Okay. What we are regressing on the independent variables. Here, what we're doing is we are regressing the log of odds ratio on the independent variables. So the change in independent variable, okay, we have to see in total with the log odds ratio. So if x1 changes by 1 unit, what is the change in the odds ratio of y? I getting it. What is the change in odds ratio? For example, what is the technology the farmer is using? What is the change in the technology that the farmer is going to use, whether he will be using it or not? So in that way, from simple linear regression, now we understood what is logistic regression. Simply, we can say the response. The response variable over here is simply y, but here it is, that is the natural logarithm of the odds. So that is why we have log of odds ratio. So instead of y, what we have is we have log of odds ratio is equal to the regression expression, the regression model. Okay. Instead of y, we have log of odds ratio. So we should know what is odds ratio. Odds ratio, it is p upon 1 minus p. P is the probability of the event happening. P equal to 1. 1 minus p refers to the probability of the event not happening. So it is all about the probability. In regression, what we're doing is if x1 changes by 1 unit, now then y changes by how many units? Then we have beta 1 right over here. So if x1 changes by 1 unit, y changes by beta 1 units. But here, if x1 changes by 1 unit, then this beta will tell us what is the probability of the event happening or not happening. Okay, if x1 changes by 1 unit, what is the probability of the event happening or not? So this is what is the interpretation in case of logistic regression. Okay, so now we should learn about the keywords. Okay, the keywords is in regression, we simply estimate it by just having the actual value of y and x. But here we have to make some kind of adjustments. Okay, instead of having actual values of y, what we have is we have logit, that is natural logarithm of the odds. So this regression model is much the same, but instead of y over here, what we have is we have log of odds ratio. And we should know what odds ratio is. It is the probability of the event happening to the probability of the event not happening. That's it. Okay, now you see, so we know very well this is a PRF or SRF, population regression function or sample regression function, or we can also call this as sample regression line test. Now you see here, y is taking only two values, 0 and 1. Okay, so we don't see any of the predicted values over here because it is possible for us to have only 0 and 1. Now here, if we are estimating probability, then it is always possible for the probability to exceed 1. Okay, if you are using a linear regression model in estimating the probability, because this logistic regression, as I told you, the interpretation part is what is the change in probability. Okay. If x changes, so here the probability may exceed 1, but the probability should be within 0 and 1. The coefficients, that is the betas, okay, betas can take any value from minus infinity to plus infinity, but the probability should always exist between 0 and 1. So in that way, the straight line is of no use. In logistic regression, the curve is sigmoid curve. So in the sigmoid curve, this helps the predicted y value to lie between 0 and 1. Okay, so this is what is all about logistic regression, where we have S curve, sigmoid curve, instead of straight line, because here the outcome variable is the log of the odds ratio, not simply y. Okay. So now the thing is that, so we know what is log of odds ratio, right? Okay. So as we have seen, log of odds ratio is equal to the specification of the regression. But the thing is, how to convert this log of odds ratio into probability? How we are going to convert this log of odds ratio to probability? Because the interpretation is what is the change in the probability level. Okay. So how we are going to do that? Okay, for that we need some algebra. So we know odds ratio is equal to P of P upon 1 minus P. That is the probability of event happening to the probability of event not happening. So we are interested in this one, the probability of the farmer adopting a technology. So what is the probability of the farmer adopting technology? If the farmer, we are taking response from the farmer, right? From 100 farmers, we have taking into account his socioeconomic characteristics, his returns from the farm, his yield characteristic, everything. So we have on the different variable side, we are asking whether the farmer is adopting a technology or not. So we have 1 0 0 0 1, and then on the right hand side we have the information about all the independent variables like age. We have got continuous, age of farmer, then education, then we have got farm size. Okay, then we have got returns, everything. Now we have to see what is the probability of the farmer accepting a technology. Since the different variable has got binary outcomes, it is not possible for us to use a regression model. Otherwise, we can say if age increases by 1 unit, the technology will increase by so and so unit. That is possible for us to say. But the thing is that the probability of the farmer adopting a technology should lie between 0 and 1. In the case of linear model, it is not possible, right? Now, we are interested in finding P. So how to get this P? So the probability of the event happening, P, will be, so we can take this 1 minus P to the odds ratio side. So what we can have is 1 minus P into odds is equal to P, right? Then what we can do is we can expand this. So when we multiply, then we can 1 into odds. So minus P into odds is equal to P, right? Then we can take minus P into odds to the right hand side. So we simply have odds is equal to P plus P into odds. Then we have odds is equal to taking the P out because it is a common, right? So P into 1 plus odds, right? Now we can know what P is, right? So P is nothing but odds divided by 1 plus odds. So this P, the probability ranges from 0 to 1. However, the log of odds can take any value from minus infinity to plus infinity. Okay. So we know it very well. Instead of y, we have got log odds ratio. So log odds ratio is equal to the intercept as well as the parameter or coefficient, you can say, and the independent variables. Okay. The regression specification. So instead of having to deal with the entire model, we can simply say the entire regression model is equal to Z. Okay, so what we have is, we are simplifying it, okay. So log of P upon 1 minus P equal to Z, because this Z represents the entire regression specification. Now you see, as the probability is function of Z, okay, the probability is function of Z. What is Z? Z is the regression specification, where we had intercept, we had coefficients, we had all the independent variables, and the error term, okay. The probability is a function of Z. Then if we are taking this log out, then we have P upon 1 minus P equal to e to the power Z, right? Then we have to find what probability is, right? So then what we can do is, we can take 1 minus P this way. So P is equal to 1 minus P into e to the power Z. Then upon further transformation, as is shown over here, simply by rearranging, what we can have is, simply we can have P is equal to e to the power Z upon 1 plus e to the power Z. Something like the same, odds divided by 1 plus odds, but here we are bringing in the regression model. This Z is the regression specification. Okay, this specification is Z. Instead of Y, we can have Z, right? Or what we can do is, we can always, instead of writing this, we can further simplify it in this form, okay? If you are dividing by e to the power Z, then we can have 1 over here, and then 1 plus e to the power minus Z, okay? Now you see, logistic regression is considered as a generalized linear model, okay? So this is the probability, which is a function of Z. How we are able to find it? We can find this probability by using this, right? Odds by 1 plus odds, or simply, if you are bringing in the regression model, then we have e to the power Z by 1 plus e to the power Z, okay? So this probability of the regression of the logistic regression is nothing but, it says that it's a generalized linear model because the outcome, that is a probability always depends on the sum of inputs and parameters, because without the regression model, the probability is of no use. We won't be able to find. So the probability can be traced only by the regression model, which is again nothing but the sum of inputs and parameters. Now we have got all the inputs. We have BIXI, right? Then X1 plus X2 plus X3. Then we have all the independent variables will have their corresponding parameters or coefficients. So beta 1 X1 plus beta 2 X2 plus beta 2. So this logistic regression can be considered as a generalized linear model because the outcome depends on the sum of the inputs and parameters. Only thing is that in a case of a linear regression, y is a continuous dependent variable. But here, what we're doing is we are regressing for the probability of a categorical outcome. So what we're regressing over here is we are not regressing y on x, but we are regressing so as to obtain the probability of a categorical variable. So the probability of y is equal to 1. That is the event happening, or the probability of the farmer accepting a technology. That is the event happening, y equal to 1. If it is y equal to 0, then the probability of the farmer not accepting technology, or the probability of the event not happening. So since here we have probability of y equal to 1, that is the probability of a farmer accepting a technology. There's nothing but instead of z, what we're doing is we are expanding it. Now we know what z is, right? Z is the actual regression specification. So when we are when you are incorporating over here, it becomes 1 divided by 1 plus e to the power minus the regression specification. Now, when we run the logistic regression, and then we'll be obtaining beta naught intercept. Apart from that, we'll also obtain the coefficients or parameters of the independent variables. If you have got 3 independent variables, then we'll be having 3 parameters depending on that. Okay. Now here, as I could see very well, we are not using OLS estimator. Okay. What we're using is we are using maximum likelihood estimator. We know what OLS is, right? It is distance minimizing approximation. The distance has been minimized. Distance of what? Distance of the we have a regression line, right, which is predicted. So that is predicted by the regression model itself. But we have actual values of y. So the actual values of y will be above and below predicted line. So that actual value of y, the distance from the predicted line should be minimum. Then we are coming up with a model with minimum distance. Okay, then we can say that is the best model because we have TSS, which explains total variation. Okay, when the distance is more, then the estimated model is not able to explain total variation completely. Only a certain part of total variation is explained, for example. Okay. So that is what is about regression. But here what we are going to use is we are dealing with probability, not about the actual value of y. So that is why we are going to use maximum likelihood estimates in arriving at the probability. Okay. Here, as you could see, in OLS, we do not use any kind of stochastic assumption, random assumptions. Okay. We need assumptions only for justifying that the estimator, that is OLS estimator is blue, best linear unbiased estimator. That's it. But here, the MLE starts by assuming a joint probability density function. Okay. This MLE assumes a joint probability density function. Okay. Now, how to estimate logistic regression MSX? So we have to follow all these steps. As you could see here, once we have the data, we have to set beta values. Okay. If you have got 3 different variables, then you'll be having 3 beta values, that is 3 parameter values plus 1 intercept, right? So we'll be having 4. We have to set. We should give some random number like 0.01, 0.02, some random number we have to assign. Why we are doing it? For later optimization. Okay. so that we can optimize data. This is what is important, optimization. This optimization cannot be done in simply data analysis package. For that, we have to use solver package. In Excel, MS Excel, the solver is also an add-in package. So I think in the previous semester, while I was telling you about the need for adding in data analysis package, I also told you to add the solver package as well. So if you're not done it, you go to add-in and then you just find solver package, you have to tick it, and then it will be added along with data analysis package. It's as simple as that. You know how to do it, right? And then once you have done it, in normal regression, what we'll be having is we'll be having predicted value of y. Like we saw, we have actual value of y and then we have predicted value of y. So as to have further estimations. But here, instead of predicted value of y, what we'll be having is we have logit. So accordingly, apart from y and x columns, we should have all these additional columns. We should have logit. We should have e logit because e to the power z, right? So e logit. Then we should have probability and then log likelihood. So we should have all these 4 additional columns. Okay, what is logit? As I told you, in logistic regression, outcome is about the product of the parameters and their independent variables. Okay, so whatever values we have of the intercept and the coefficients, and then we have the values in x, we have to find a product. So that product is logit. Then what we have is we have e to the power logit, which is nothing but exponential of logit value. So whatever logit value we are getting, for that we have to find exponential of it, exp. Then it is the probability of logit. So in the earlier case, we saw, right, what is probability of the event happening? E to the power z divided by 1 plus e to the power z. Similarly, over here we have e to the power logit divided by 1 plus e to the power logit. Then log likelihood. That is, we have to take natural log of the probability. Then sum of log likelihoods, the optimization. So this sum of log likelihoods should be maximum, should get maximum. Then only the model will get converged. For example, I told you now we'll be having iterations. Iteration means repeatedly the software will take care of it. We'll do again and again. Like it will go step by step. If it is iteration 0, it won't take any of the predictors. That is, in the model, it won't include any of the explanatory variables. And then it will include one by one. So it will have iterations. So when it does iterations repeatedly, the analysis again and again, then the value of the log likelihood will improve. And then it will converge the point where log likelihood is maximum. So only when the model is converged, that is, the log likelihood becomes maximum, that is the point the model will stop running and it will give out the results. If there is no convergence happening, it means what? The maximum point is not achieved of log likelihood. Okay. That is why we go for optimization, because it is not possible for us to do manually again and again, and we have to leave it to the solver, or we have to leave it to the some basic or advanced statistical software. Almost all the software does optimization. It's very easy in Stata. In Stata, as I told you, simply you have to just type logit and then you have to introduce the dependent variable, whatever dependent variable we have in dichotomous values, right? Along with that, you introduce all the independent variables. So in one click or in one press of the enter button, what you'll be getting is you'll be getting results of logic. But here you'll be able to understand it only when you do in Excel. Now that you understood what is regression and what is logistic regression. The regression is all about actual value of y, and then we have the model running. Okay, when we run the model, what we get is we get predicted value of y. Using that predicted value of y, what we have is we have a regression line. And in that regression line, we have the actual values of y, which will deviate from the regression line. So the more the deviations are, the more imperfect the model is. So the model should be more perfect, the deviation should be less. So that is what is about regression, right? In that way, what we are going to do is we have to see that the y is continuous. What is continuous? That it can be, divided into small parts. So you can divide into small parts, like you can have income as a continuous variable. You can have yield as continuous variable, because a farmer can have 2,000 rupees as income, 2,000.12 as income. Yield, a farmer can have 12 quintals or 13 or 13.1, 13.2. So like that, it can be divided into fractions, continuous variable. But here we have categorical variable. The different variable is whether the farmer is adopting a technology or not. So 1, 0, 1, 0, like that. If you have got 100 farmers, then we have 40 farmers adopting, 60 not adopting. So you are assigning them some value, 1, 0 value. So there, instead of having actual LFI, what we have is we have odds ratio. So then what we are doing is we are taking the natural log of odds ratio. So natural log of odds ratio becomes logit. What is odds ratio? P upon 1 minus P. The probability of the event happening to the probability of the event not happening. So here we are focusing on the probability part of it. So when we interpret, so if X increases by 1 unit, what is the probability of the event happening? If beta coefficient is 0.4, then we can say the probability of event happening is 0.4. Something like that. It all depends upon the probability. Or we can express in percentage. If X changes by 1 unit, the probability of the farmer adopting a technology increases by 40% if beta happens to be 0.4. So in that way, what we're doing is, instead of using linear regression, we are going for logistic regression, and we are fixing the values of y between 0 and 1. Okay, because probability should be between 0 and 1. Instead of logistic, if you have gone for linear regression, and if we are estimating it, we can see that we won't be having any values around the regression line, because we have only two sets of values. We have 0 or 1. In that way, now the value of the predicted y will be more than 1. If it is more than 1, it is not making any sense. We won't be able to predict the probability at all. So now, as I told you, in MS Excel, we can do step by step. So apart from having y and x, we have to add 4 more columns, that is logit, e to the power logit, probability, and log likelihood. Apart from that, we should use solver function, where to optimization. In solver, it is, you see, this one is the solver window. So here we have the y, and here we have the x. Now we have got only one independent variable and one dependent variable. And then you see we should have logit, and then we should have odds of the logit, and then the probability, then log likelihood, or likelihood equation, then log likelihood. Okay. In solver, what we are doing is, you see here we have a target cell. First, number 1, target cell, then changing cells. So what we have to change? We have to say change this coefficients, because we are setting, like I told you, right? The first step in logistic regression, we have to set some initial values to beta. Here we have only one independent variable. So what we have over here is B1. This B0 is intercept. It is going to be there. Apart from that, we have B1, which is the initially we'll be setting some 0.01 value, and then when we do with solver, we'll be reading the value over here after the model get converges. So this is the changing cell, and we have to set maximum, because we have to obtain maximum likelihood, not minimum, right? That's it. There is nothing else over to do. Don't go to anything. Everything is default. Just set target cell. What is target cell? Target cell is the sum of the log likelihood. So once you have log likelihood, if I've got some 20 observations, for each observation you'll be having log likelihood, right? And then you have to do summation of log likelihood. This sum should be maximum. Only when it is maximum, the model will converge, and it will give you the value of the beta coefficient, right? So that's the target cell. Sum of the log likelihood, summation of the log likelihood values, and then changing cell is the beta coefficients. And then you solve, you'll be given this one. Okay. So in solver function, set objective, and then you have to, that is the target cell. And then you have to choose the changing cells. The cells pertaining to the beta coefficients will be the changing cell, and the cell pertaining to the summation of the log likelihood values will be the target cell. That's it. Okay, so this is the interpretation part. So once we finish in Excel, how to do logic in Excel, then we have to come to the interpretation part. We'll come to this part later. Okay, let us see first how to carry out logistic regression in Excel. Okay. Okay, fine. Here we have got the different variable adoption of technology. Okay. And then what we have is we have independent variable, right? Did I lose control somewhere here? Just a minute. I'm just checking it. Okay. I think you're with, right. Now I'm sharing it. Okay, fine. So we had adoption. Okay. And then this adoption is the different variable, or you can see it is dichotomous, binary, right? 0, 1, 0, 1, 0, 0. This yield is continuous variable, and this returns some dummy, some hypothetical data, okay? And then we have efficiency, okay? So like I told you, apart from this is the your dependent variable, and all these are your independent variables. Let me just zoom this one. Now the first column is logit, okay? So in logit, what I told you before setting logit, most important thing is we have to set the initial values of the beta coefficients, right? So here we have got 1, 2, 3, three independent variables. So we'll be having 3 beta coefficients, and then we should have intercept. Okay, so let us have B0, B1, B2, B3. Got it? So 0.001. Okay, 0.001. Some initial value, not higher range value, because it will prove difficulty while estimating, because we have to use solver function, right? You see here, this is the solver I was talking about. So which you can always add in. You go over here and then the option. Okay, here the Excel options. Here you can have add-ins. You can always add in a solver. Okay, you have to go there and then you have to click. You have to go add in, and then if the box is unticked, you have to tick the box, and then you'll be having the solver package along with data analysis package. Okay, so now what we have is we have the beta coefficients. We have set the initial values to it. Now the first column, as I was talking to you about, will have logit, L-O-G-I-T, first column, right? So what is the first column all about? It's about the product of the coefficients and the independent variables. That is what is logistic regression. That is what is called a generalized linear model, because its outcome is dependent on the product of the coefficients and the independent variables. Okay, so 0.01 plus we have beta 1 into x1. What is x1 over here? This is x1, right? x1 plus beta 2 into x2 plus beta 3 into x3. Good. Right. Now we can drag. Here we should be very careful because we have to fix values. These beta coefficients need to be fixed. The independent variable values can vary because we have got a number of values, but we have to fix the beta coefficients. How to fix it? I have told you already. We have to go for, use F4. When you use F4, it is fixed. Now you see, we have got $2 symbol over here. It is fixed. Similarly, what we have to fix? We have to fix F2 as well. So fix F2, fix F3, fix F4. That's it. Now we are fixed. Once we have fixed, then if you are able to drag, you see now we are getting logit. Then next, what you have to find? We have to find e to the power logit logit. So simply go for exp, exponential of the logit value. So this is what you're getting. Then what? The third column, what we have to have seen? Probability, right? So probability, the probability of the event happening. Okay, what is the formula? E to the power logit divided by 1 plus e to the power logit. Okay. Now here we have likelihood. What is the likelihood of the event happening? So here we have to use if function. If, what is if? If the farmer is adopting technology, that is A2. A2 is 0 over here, but suppose if A2 is equal to 1, that is, if the farmer adopts a technology as the response given by him, but here the response is 0. But suppose the farmer has given a response that he is adopting a technology, then we have to use this as the probability, value of probability. If not, what you have to do? If not, we have to go 1 minus the value. Okay, you see again, if A2, the column over there, right? If A2 happens to be 1, that is, the farmer has indeed adopted technology, then this, the probability value over here, given over here, is sufficient. If not, we have to estimate, we have to find a new value, which is nothing but 1 minus P. That's it. Here it is 0.4945, which is 1 minus P. Why? Because the farmer has responded, in this case, that the technology has not been adopted by him. And then when we drag, so here the value is same, right? Because here the farmer should have said that the technology has been adopted by him. You see here 1. So when the farmer has said, yes, I have technology, then you'll be having 0.506. Okay. So depending on the response given by farmer, we have likelihood. Then what we have to do, we have to find log likelihood, right? LOG. Even though I'm going for log likelihood, LOG likelihood, it's actually natural log. Okay. So natural log of likelihood. Likelihood. So what I do is ln, natural log, right? Log base E. E raised to the power of what gives this value? You remember, right? We're talking about this. E raised to the power of what gives this value? Yeah. Okay. Then what we have to find? Summation of log likelihood, because this is the target cell. So go for summation of the log likelihood, which happens to be a target cell. So this cell has to be targeted, and this cell should change because the values over here are assigned. When we are assigning some values over here, then the model should run, and it should converge, and then it should give us the optimized values. Okay. Now let us go to solver. So we understood, right? It's very simple. Look at the different variable. It is not possible for us to use linear regression estimations, OLS. So what you do is we have to find here that we are not going to use actual y value. We are going to use the log of odds ratio as the y value. So the log of odds ratio is equal to the regression model, regression specification, right? So then for that, we have to introduce some 5 more columns, right? We have to go for what is logit, what is e to the power logit. Then we should have probability, likelihood, then log likelihood. What is this logit all about? As you could see, it's very clearly, it's nothing but the product of the coefficients and their independent variables. Once you know this one, everything else is easy. E to the power logit, as name indicates, exp. So antilog of this one. So antilog of logit is 1. You're getting E logit. Then probability is nothing but, as you could see over here, the formula which we have seen earlier itself, right? What is the probability of the event happening? So E to the power logit divided by 1 plus E to the power logit probability. The likelihood, where we used if function. If the farmer happens to adopt technology, then this value is sufficient. Otherwise, we have to go for 1 minus the value, the value, that is the log likelihood. And then taking the log of this likelihood value will give us log likelihood. And then we have to find summation, because the summation will be the target cell. We have to target some cell. Why? Because this value should be maximum, right? Right now we are getting minus 8.30, right? This minus 8.30 is the value which we have obtained by assigning some values to the beta coefficients. This is not right. So we are get maximum value. So that is why we are going to use maximum likelihood estimates. Then data, go for solver. Then the target cell is what? Perfect. Target cell is perfect. Excel has automatically selected. Now changing cell, we have to change all these things. Okay. Now there is nothing for you to do. If you go to options, nothing you have to check. Don't check anything. That's it. Okay. There is no need to add any constraints. especially in linear programming right now, we used to add some constraints over here, but that is not needed at all. Simply, you just solve and give me the maximum value of the likelihood, and then give me the beta coefficient values. Let us go. Yes. Yes, we have got, you see, from -8, it has increased to -5 because the -5 is more than -8, right? So the value of the log likelihood is maximized. And then we also obtain the beta coefficient values. So we can keep solve a solution. If you're not getting optimization over here, then you have to run again and again. Somewhere you must have gone wrong. You have to check where you've gone wrong, whether the logic formula or whether either about logic formula or the probability, likelihood, or log likelihood, everything you should be clear. So only then you will be getting the maximum value of the log likelihood along with the beta coefficients. Now we have obtained. Good. So, okay, fine. Right. So far we know what is logistic regression and how to estimate logistic regression in Excel. Now comes the major part of interpretation. Okay. So here, if you could see the interpretation part, the results which are given by Excel in logistic regression, default they mean P is equal to 0. Okay. The beta coefficients that we are obtaining refers to the event not happening, P equal to 0. But we want to see what is the probability of the event happening, right? So what we can do is, instead of this, so we can reverse the sign of the coefficients. So this is P equal to 0, probability of the event not happening coefficient. Then we should have P is equal to 1, probability of the event happening. So what we can have is 3.6812. Now we are reversing the sign. Then 0.11283, right? Then 0.39568, right? Then 0.67954. And in these two cases, we haven't reversed the sign. So let us reverse it. So from plus, it becomes minus. Similarly over here, from plus, it has to become minus. In that way, now we can relate the coefficients with the probability of the event happening. Now we have to fit in this in the model. So we have seen what is the probability of the event happening, as you can see here. So the probability of event happening is a function of z. What is z over here? Z, as you know, is the regression specification, which will have the intercept and the beta coefficients and the independent variables, like over here. The intercept, then we have beta coefficient, right? B1x1, B2x2, B3x3. So we have to use this formula. P is the probability of the event happening is function of z, which is nothing but e to the power z by 1 plus e to the power z. So here we have the coefficients, and here we have the x variables also. Now we have all the x variables. Now let us see. Okay. So you have to find what is e to the power z, right? So exp plus, let us have one value. Okay, we have to see if the farmer is obtaining a yield of 21 quintals. Okay. We are selecting intercept, and if the farmer is obtaining yield of 21 quintals into what we have is, or reverse, we should have first this one, right? The coefficient of the first independent variable. If the farmer obtains to have yield of 24 quintals, for example, then the coefficient of the second variable, and if his returns happen to be some 11,000, for example, 11,000 returns, then his input use efficiency increased 11 times. If the farmer happens to obtain 24 quintals of yield, Okay, fine. So now we have to find 1 plus e to the power z. So 1 plus this one. So as per the formula, e to the power z divided by 1 plus e to the power z is giving me 0.00433. And if I'm multiplying this with 100, what I'm getting? 43281. So it is, the value is less than, if you are seeing this value, it is very much less. Okay. So the farmer is not following technologies in this case. Let us try to change the value and see. Okay. Now, if the yield happens to be G15 is okay. If the yield happens to be 21 quintals, then if the returns happen to be 6,000, then efficiency happens to be 5. Then we are getting 0.56. So any value more than 0.5, it means the farmer will adopt technology. So some weird combination we are getting because it's hypothetical data. So 0.56, this means what? Given the x values, whatever x values you have set over here, okay, like 21 quintals of yield, 6,000 rupees, and 5 times more efficiency. In these conditions, if they fulfill, then the probability of the farmer adopting a technology will be more because the value is coming to be 0.56. So any value of probability more than 0.5 means the farmer is accepting a technology. So if we have real data, then when we will be running, right, we'll be getting more better results. Okay. So now, right now we understood, right, how to obtain it. So this 0.56, the value of more than 0.5 will tell us whether the probability of the event will take place or not. In the case the event is technology, whether the probability of the farmer adopting a technology will happen or not. Here we can say that the farmer will adopt technology, obviously because the P happens to be more than 0.5. Okay. Now thing is that we have to see the influence of the individual coefficients on the probability. So this is overall. If X is so, if X is not so. But what about the effect of the individual coefficients? Like in regression, what we are doing is we are saying the partial regression coefficients. Keeping other variables constant, what is the effect of one independent variable on Y? Now, like that, how we can find over here. So what is the effect of one independent variable? For example, what is the effect of beta 1? Keeping beta 2, beta 3 constant, what is the effect of beta 1 on the probability? Okay. So for that, what we have to do is we have to find odds ratio. So again, we have to, so this is the coefficient. From the coefficient, you can find odds ratio. Since we are no more bothered about intercept, let us drop it. Let us not use it now. So odds ratio is what? EXP of the beta coefficient. So now we have obtained odds ratio of beta 1, beta 2, beta 3 by simply using the antilog function exp of this value of coefficient of beta 2 will give us the odds ratio. Now the probability is equal to odds ratio of xi. I can be anything, right? Here we have 3, right? I can be 1, 2, 3 minus 1 into 100. Okay, the probability is odds ratio minus 1 term. So we know what the odds ratio is, how we define odds ratio from the coefficients. Let us substitute over here. Okay. So odds ratio minus 1 into 100. Minus 10. Okay. Here you can see minus 10, 48.54, 9729. You can say for every 1 unit increase in X1, the probability of the farmer adopting technology gets reduced by 10% or 10.66%. Here, for every 1 unit increase in x2, the probability of the farmer adopting a technology increases by 48.54% and 97.29% accordingly. So this way you can interpret. So now we are going interpretation whether the farmer will adopt technology or not. Okay, by using the coefficients, what we have done is, since the coefficients by default give the p equal to 0 response, but here the response should be p equal to 1. Accordingly, we are changing the sign, and then we are saying if x is so and so, what is the probability of the farmer adopting technology? Then what we are saying, we have to see the contribution of individual independent variables to the probability. So there we have to find odds ratio, and then the probability is something about odds ratio minus 1 to 100. If you are using this formula over here, by using this formula, what we are doing is we are finding the probability. Okay. So this is the probability. The spelling is wrong, but don't mind. Okay. Right. No, spelling should be right. Probability. Okay, probability. Right. So minus 10, 40, 29, but here you can how to interpret now. For every 1 unit increase in x1, the probability of the farmer adopting technology decreases by minus 10.66. And on the other hand, for every 1 unit increase in x2 or x3, x2 and x3, the probability of farmer adopting a technology increases by 48.54 and 97.297% respectively. So this is what the interpretation is. Okay. Now, if you go over here, let us see the interpretation part over here. Based on all these things, okay. Like I told you, by default, the coefficients are used to find the probability that the response will be 0. So, for all the values, okay, to find the probability of response equal to 1, we are just interchanging sign, okay. And this is more important, there we can find the contribution of the individual, the independent variable to the dependent variable, that is probability. Okay. So by using the odds ratio, the probability, that is odds ratio of xi minus 1 to 100 will give us the probability of adopting a technology. Okay. In this way, right now, what we have done is we have understood the logistic regression function, as well as we know the estimation part of it. And then we also know the interpretation part of it. The estimation is very easy. Why it is very easy? Because in estimation, we need to have logit, e to the power logit, probability, log likelihood. Okay, that is very easy. No need to worry about that. And then we should know how to use solver. In solver, just two things we have to remember. We should know what target cell is. Sum of the log likelihood, sum, not SOME, sum, that is addition. Sum of the log likelihood will be target cell, and then changing cell is the beta coefficient, because here the cells have to change because the initial values that we have assigned. And then what we are doing is, once we are running regression over here, all these things are very easy. There is nothing to be confused about. We should know what logit is. That is why it is called as a generalized linear model, because the response is about the product of the independent variable and their coefficients. Okay, and then we know how to find E logit, and then also probability, the formula which is very clear right from the first that I'm telling you. Then likelihood, this is very important. Here we're using if function. If A2 is, what is A2 over there? The first column, that is the responsibility farmer, whether he is following the technology or not, or whether he has taken up training or not, or whether he is a member of a particular society or not, or whether he is a part of NABARD run FPO or not. So you can have any kind of dichotomous variable over there. So if A2 happens to be 1, that is the probability of the event taking place, then we can have this one as such, or otherwise we have to find 1 minus this as the likelihood value. Once you have done this, then just take natural log of it, and you have to just keep this as target cell, nothing but the summation of all the log likelihood values, which is as per the observations that you have. When you have it, then you have to run. When you are running it, you have to go for solver. You know how to use solver, right? So data, go for solver. This you know how to use, which is your target cell. This is your target cell. And then changing cell, all these we have to change. Once you change, then you solve, don't do anything else. That's it. Okay. Once you have done it, you'll be having the values and the interpretation part of it. As we have seen, the response is nothing but p equal to 0. We have to change the sign. Then we could find, for example, if you are setting the x values, okay, desirably, then what is the chance of the farmer adopting a technology? That thing is one. But here we have to see, just like an ordinary linear regression model, what is the contribution of the independent variable to the dependent variable? So that what we have to do is we have to find odds ratio first, and then we have to use a formula. The formula is probability equal to odds ratio of the concerned independent variable minus 1 into 100 will give us the probability in terms of percentage. Then we can interpret, like I have given over here, if x increases by 1 unit, the probability of the farmer adopting the technology or whatever the dependent variable is increases by or decreases by so and so. That's it. So with this, we'll stop this class. Thank you. Okay, thank you for your patience. If you have any questions, you do ask me.